I can actually very recently, if all of you would have heard about the CSIR Aroma mission and the Purple Revolution that was initiated by CSIR through the cultivation of lavender crops, especially in J&K, various districts, Doda, Kishtwar, etc. And these are high yielding, high value crops. So this is one mission that has been actually taken up by CSIR. You would have also heard about CSIR IHBT, which is in our institute sister concern in Palampur in Himachal. They have actually been successfully promoting the cultivation of hing in the higher altitude areas, especially in Lohal. So that's another way that we are actually trying to help in these new technologies in agriculture. We ourselves in IMTECH actually have initiated, so this was a request from Himachal government. This is the Prakritik Kheti Kushal Kisan Yojana in Himachal Pradesh. They actually came to us to look at a more scientific way of natural farming. There are various natural farming methods that have been adopted through Subhash Palekar Natural Farming Mission, SPNF, which actually promotes various low-cost climate resilient agriculture techniques for soil fertility enhancement, as also for plant protection. And we've been asked to see if we can actually look at the microbial contribution in natural farming, and we are actually quite excited in taking this forward, and I'm hoping that we would actually be able to provide them scientific basis of all these things, because that's something that is required very, very much in our natural farming system. So that we are hoping in the next few years we would be able to give logical answers to natural farming, because that's required and is really a time for it has come. Other initiatives by CSIR institutes have also been taken. For example, Kisan Sabha app, which was developed by CRRI, which actually promotes the collaboration between farmers and transporters, so that there is a very quick logistic agreements between the two parties, so that things don't go waste. Similarly, you would have heard of the floriculture mission of CSIR, where CSIR is working on developing and dissemination of technologies for development and promotion of floriculture sectors on scientific lines. And this is another way of trying to help the farmers in improving their incomes and to actually develop an entrepreneurship ecosystem through these high value floriculture using the technology that we have developed. In addition to the biological components of the CSIR mission, it's also farm machinery that actually has been taken up by CSIR-SEMIRI, which has actually initiated a farm machinery training and testing center to expedite the pace of farm mechanization. And we know SEMIRI for tractors which like Swaraj, Sonalika, Krishi, Shakti, but now they are slowly transitioning also towards a new domain in the form of e-tractors, compact tractors, and so on, e-power tillers, and so on. So all in all, the thing that I wanted to actually bring to you was that we in CSIR are trying to deliver sustainable and efficient technology solutions to farmers for mitigating challenges. And this CSIR's initiative in Ladakh, the Science, Technology and Innovation Hub, STI Hub, in Ladakh is another way or another reason why we are trying to show that we are really committed towards serving the society. And uh, we hope that our interventions through this, for example, this workshop would help in long way helping the farmers in adopting newer and futuristic technologies for farming. So I once again welcome you all to this two-day workshop. I'm looking forward to various talks, especially that by Dr. Wangchuk. Really looking forward to your talk, sir, and hope that the deliberations in the workshop would go a long way in helping the participants in adoption of new and futuristic agriculture technologies. Let me also thank all the organizers, including Mr. Chandrasekhar, who have actually worked tirelessly to bring this workshop to you. And I wishing them all the best for this workshop, and I'm hoping that it's a happy learning for all the participants. Thank you, and back to you, Chandrasekhar.
Thank you very much, sir, for really motivating words from you. I request Anupriya from PGI MAR to introduce today's keynote speaker, Dr. Sonam Wangchuk. Anupriya, over to you.
Very good morning to one and all present here. I would like you all to please welcome our special guest of this meeting, Dr. Sonam Wangchuk, Director, Himalayan Institute of Alternatives, Ladakh. Here is a brief introduction of his great personality. Dr. Sonam Wangchuk was born in the Trans-Himalayan region of Ladakh, India, though he is a mechanical engineer by education, but he has been mostly working in the field of education reforms for more than 27 years. In 1988, he founded SECMOL, the Students' Educational and Cultural Movement of Ladakh, which aims to bring reforms in the government school systems in Ladakh. As an engineer, Sonam Wangchuk has been teaching innovation in the SECMOL Alternative School, where together with the students, he designed and built solar heating buildings that are low cost, made of earth mud, which can maintain a temperature of 15 degrees Celsius when the outside temperature is minus 15 degrees Celsius in Ladakhi winters. In order to solve the water crisis facing mountain regions due to climate change and fast melting glaciers, he also invented the ice stupas, also known as artificial glaciers, which stores the wasting steam waters in winters in the form of giant ice cones or stupas and releases the water in the late spring as they melt. Dr. Sonam Wangchuk has been granted several awards and titles, such as the prestigious Ramon Magsaysay Award 2018, the GQ Man of the Year Award for Social Entrepreneur of the Year 2017, and the Rolex Award for Enterprise 2016 in Hollywood, USA, and the Terra Award 2016 for the world's best earth building in Lyon, France, the UNESCO Chair for Earth Architecture for India in 2014, Real Heroes awarded by CNN IBN Channel in 2008, Green Teacher Award by Century Asia Magazine in 2005, Ashoka Fellowship by Ashoka, Innovators for Public in 2002, Man of the Year by the Week Magazine in India for 2001, and the Governor's Medal by J&K State Government in 1996. Sir, we feel really obliged that you have joined us today over this virtual meeting. As we already know that what a great personality you really are, we want you to kindly share some of your great experiences, views, and thoughts with us today. Thank you.
Thank you. Thank you very much. Can you hear me?
Yes.
Okay. Good morning, all of you. I'm really happy that you all are doing a lot for promoting science, technology, and innovation in Ladakh. Congratulate the STI Hub for organizing this, and CSIR and IMTECH and PGIR Chandigarh for supporting. Grateful that we'll be promoting solutions for this very different kind of environment and climate that Ladakh is, and helping Ladakh find its own contextual ways of solving problems. I very much hope that this workshop will go a long way in finding such solutions. Regarding the subject, I'll share some of my experiences and observations from Ladakh, and look forward that we can collaborate in future. You know, all of us who are working towards such solutions should share our experiences, successes, and more importantly, failures to learn from and go forward. So thank you everyone for organizing this and for inviting me here. Just a few thoughts, and then I'll share some images of our experience, our work in Ladakh that we can in future further share. While talking about futuristic technologies in sustainable agriculture, I was first thinking that to make life sustainable on the earth, where it is getting so complicated that we have forgotten living simply, some of the more futuristic things to do are some of the most ancient thoughts. Like 30 years ago, I think a film was made called Ancient Futures, based on a book by Helena Norberg in Ladakh, on Ladakh. So some of the most futuristic things are what our ancestors teach us. So when we talk of agriculture and sustainability also, I think futuristic technologies should not always mean, you know, digital solutions and high-tech robotic solutions only. Some of the most futuristic ones could be found in how our grandmothers used to teach us. We may apply any technologies in producing food, but if we do not value the products and waste, much of our cutting edge technologies will go to waste. So today, the most important technology, if you want to call it, that is needed is, especially among young people, children, so that they make it a part of their life, is the simple lesson of grandmother not to waste food. If we stop wasting food, half the population of the world can be fed. We waste 30% or more of the food we produce. And if we continue to waste the way we do, then what's the point of going for higher and higher technologies, which are often more and more polluting, more and more complicated, more and more, you know, disbalancing for the planet. And then at the end, if our consumers, our children, live with this spoiled, you know, habits of wasting food, then it doesn't make much sense. So some of the things we need to do are as much to go back towards our values of our ancestors as to go forward with our high-tech solutions. I'll share with you a little later how the first priority, I think, is to educate every young person, every child, not with the latest cutting-edge technologies, but with the simple Nani Ma's recipe of not to waste. And that will take care of the hunger and the pollution and the insustainability of development. Then next, it's The most effective ones are the simplest to understand, but not as simple to bring into practice, because it takes a culture that our ancestors had much stronger than we do. For example, as I said, we just don't value the products we have developed with all these technologies, and 1/3 of it is wasted, and India unfortunately is top second in food waste. So we have to as much lay our emphasis on that. When we educate our young people, let's also educate them about the value of all resources, especially food, which is so important. Then coming forward, again, some of the most important technologies come from the most ancient practices. So to help grow, we don't always need to, bring resources like fertilizers and minerals from breaking air molecules. So our technology should not always be how to break nitrogen from air. N2 is broken into nitrogen, NPK, and that is such a costly and energy intensive process for which so much of our electricity is used. I'm sure many of you know, because you are connected with agriculture or scientific research, that artificial fertilizers are a great polluter, resource intensive, particularly electricity. And in a country like India, more than 70% of electricity comes from coal. So we are polluting our air in making these fertilizers, and we are depleting the earth, which has sequestered all the carbon to make the air healthy. So we are releasing the carbon back into the air to get fertilizers artificially from breaking molecules of air. And that is not futuristic. That is some transitional development which our future civilizations will best want to forget, that we even had a phase where we were using or misusing energy, especially from coal, to make fertilizer by breaking air molecules. Whereas the fact is that half of the food we eat comes out of us in the form of human waste. And that human waste has all the good that the soil needs. And this is not a new futuristic technology. This is again an ancient future technology. In Ladakh, we have always had this technology, if you want to call it, of reusing your night soil. Not only animal waste from the stables and the cow sheds. Of course, they are reused as manure in the fields, but even human waste was recycled. There was nothing called waste. So what is futuristic to me is this kind of circular economy in which there is no waste. There is definitely no food waste. We consume as much as we need. And even from what we eat, we don't waste food, we eat. Even from what we eat, the human waste that our system rejects has roughly half the goodness of nutrients and minerals. And that is full of manure or nutrients for our plants. So why don't we recover? We need to only learn from our ancestors, our grandparents, who had these, for example, in Ladakh, dry composting toilets, which were kept to decompose. We may need to improve it a little bit, but the philosophy that waste does not become harmful like it is in these glossy, shining Western system of flush toilets. not only are we wasting the water, we are wasting the waste, which is so precious. It's not going to our farms and fields as it used to decades ago in Ladakh, and I'm sure in most parts of the world. It's not going as food for the plants, it's going as food for the wrong things in lakes, in streams, in the groundwater. So it's a lose-lose solution. So let our futuristic technologies not be for the sake of, some change, which sometimes leaves us much worse. One of the deadliest technology that we have and that we need to replace is the Western water toilet, which needs, I think, 5 times more water than we need water to drink. According to one study, it said we flush, or maybe Western cultures flush in a day what they drink in a month. So much of water is wasted, so much of nutrients that could be plowed back into the soil is wasted and goes into lakes and promotes the wrong kind of plants and kills life in lakes and rivers and seas. So we need to go back again to that future where we have solutions like use your waste as a food for the plants and the plants you eat. So it's a perfectly circular economy. Now this is called beyond sustainable. So far we have talked about sustainable development, sustainable agriculture. It's time we need to talk about regenerative development, restorative agriculture. Sustainable means, you can sustain it. So for example, in Ladakh, if we burn cow dung, it is sustainable because we keep the cows and we get our dung and we can burn half of it and we can give the other half to the farms. This is what our ancestors did. So where is the development? We are actually going backwards. Now we are paying for something artificial which uses so much energy, so much chemicals, and spoils our soil and makes us dependent on cash, because these artificial fertilizers come with a huge amount of money which is often loaned from banks, and we can't pay. When we can't pay, our farmers commit suicide. India has one of the highest rates. So this is not development. Development for me would be that our parents were sustainable in Ladakh, where they had animals, the dung of which would be burned to keep warm or partly to the fields. We should go a step forward and make, for example, solar heating of buildings so that no dung is needed to be burnt. This is a step forward from our ancestors, not a step backwards like artificial fertilizers, but a step forward would be to empower people to use the sun for warmth and dung not for warmth, but regenerating nature. So when the dung goes back to the forest or farming or in growing trees, then it adds and enriches nature. Then it is restorative, then it is regenerative. So where our parents and grandparents were sustainable, we need to become restorative so that we can heal the earth for what we did in between our ancestors and our current new generations. There was a lot of damage done. So we need to go in restorative mode, and sustainability alone will not do. So I'll share with you what little things we have tried in Ladakh at our humble school, and now we are promoting the same things in our alternative university, where we can do a little more serious work because it is with youth in their 20s. The school was only with the teenagers, so it had its limitations. Nonetheless, there are very interesting outcomes, especially for Ladakh and other cold mountainous regions of the world. And of course, the idea and the concept is applicable for any part of the world to become not only sustaining, but restoring what damage has been done already. So I'll take your permission to share my slides, if that is okay. And let me know if you can see my slides. Can you see?
Yes. Slides are visible.
Okay. So I was starting with saying that really the most important technology or understanding or sensitivity that is needed in agriculture is not digital or robotic. It is just the simple fact that, waste not what you do so much to produce. As you can see, China and India are by far the biggest food wasting countries. We have so much hunger, yes, yet we waste so much more than others. So just by stopping wasting and not ignoring this aspect, when we talk of technologies, let's not ignore this aspect, because otherwise it will be like chasing shadows. We'll never catch it, because no matter how much we produce, wastage will take away much of it. So that's one thing I wanted to share as an important technique, technology, our philosophy that we need to teach our young people and children. Even if they are not able to develop apps or automatic machines, they can contribute by becoming on the right side, the solution side of the line. So now I'll share some things from Ladakh, as most of you would know where it is. It is beyond the Himalayas. Himalayas are lush and green like in Himachal and Kashmir, but Ladakh is beyond Himalayas. That's why it's often called Trans-Himalayas. So it is very much like another planet, you would say, or outer space. We are already closer to outer space by 11,000 to 14,000 feet than most places where you all are maybe. And therefore temperature swings are very big, plus 35 to minus 35. But what makes it different is not the dry mountains, but the patches of green, the oases, the islands of green that you can see. And it is the the creativity of our ancestors who made it possible to live in these places which were never inhabited for a long time. And since they did not have water from the skies like you all have, they used the fossilized water, if I may say, from the accumulated snow in the mountains, which is called glaciers. It's water from hundreds, if not thousands of years ago. And they mastered the craft of channelizing them by cutting rocks and then growing crops. Now, among crops also, there's a very interesting thing. Till recently, in historic terms, people could not inhabit these heights like Ladakh or Tibet. It was the discovery or invention of this breed of barley that made it possible. Barley has a very short maturing time, and therefore they could come armed with barley to these heights, which have very short summers. So thanks to barley, human habitation became possible. But today they grow not only barley, but wheat and peas and many alpine vegetables, apples, apricots, grapes, and so on, all thanks to the innovative, creative approach and very futuristic technologies of our ancestors to make these rivulets or canals in the mountains. We are a minority in this vast tropical nation of ours. We are a climatic minority and a technological minority, not just linguistic and ethnic. You know, very few things work in Ladakh that are brought from New Delhi. For example, it's quite a circus to run the tap, as you can see, people making the ice melt. So for this kind of region, it needs contextual, experimentation and research. And that's what we have been doing in a small way at our school. This is an alternative school where people say the criteria is failure, not marks and distinctions. That was because so many young people were failing in their 10th grade exams some 3 decades ago. And after working with government to change the school systems in the government schools, we then started focusing on those who were still failing. There was 95% failure in schools in those days. It came up to 75 after some interventions along with the government. And then we started focusing on the 25% who were still failing and applied whatever was in the textbooks in the real life so they could learn better. Those who were not good with books could learn more by application, and application is important for innovation. So a lot of innovations happened along the way, and I'll share a few of them. So just to tell you about how we established the campus, we used lessons from the geography and physics in the textbooks of 9th and 10th grade to know how to orient buildings and farms in a place like Ladakh. So we learn from geography that the winter sun is always in the southern sky. So all the buildings faces south so that they can get the winter sun from the southern sky. Geography in practice, in application. Similarly, we learn that in Leh area, the winds come from the west, southwest. So we started with windbreak plantation. You can see on the left, plantation to break the wind so that it doesn't make it very cold and disturbs farming. So before we built any buildings, we started with windbreak tree plantations so that the winds we learn about are actually countered. Same with sun that we learn about is aptly used. And then in physics, you have gravity. So you use your design of the campus in a way that water flows by gravity and no pumps are needed. So all these chapters in school can be used to make life meaningful and make science come alive in real life. Similarly, innovation in our context is around what I call earth, sun, ice, and fire. So earth is the soil under our feet. We use it to build our buildings. You don't need cement, concrete, etc. You have the best building material in the world right under your feet, abundant, free for all. There's nobody so poor they cannot afford soil under their feet. And imagine when it is connected with the sun, which shines over our head, free for all, abundantly. Nobody so poor they don't get sun over their head. These two coming together means you have a great habitat that you can live happily even in cold Ladakhi winters. I'll come to that later. You can see down there the chapter on heat from 9th grade science coming alive. If you remember your science, it was about conduction, convection, radiation. Down there, you can see how convection is bringing the air that is heated in the greenhouse and rises up because it's lighter into the building from the upper windows, where it loses its heat to the walls and becomes cool and dense and is pushed back into the greenhouse. The cycle continues all day without any fans or ventilators, power or pollution or power bills, and all the heat of the sun comes in. Similarly, the south side of these walls are black, and black absorbs and conduction takes place. Molecule by molecule, the heat comes into the building, and at night when you close these windows, the heat is trapped and the warm walls and floors radiate. There comes radiation into play, and thanks to the chapter on heat, you make a difference in life and people can live happily without using any heating, even in Ladakhi winters. Similarly, the sun can be used for so many things. At our school, cooking is done by sun with concentrators, parabolic, and greenhouses produce fresh greens. Lighting is all solar, natural lighting. Electricity that is needed is all photovoltaic since 1990s, when there was very little in the world, and especially in Ladakh in terms of solar energy. So water is heated by the sun, water is pumped by the sun, and even the cows in this school live in solar heated cow sheds. Now this is a very interesting area that we need to do R&D and promote, these solar heated cow sheds. I'll come to those. Some 20 years ago, after we had built our own houses, solar heated, everybody was happily warm in winters. Some of our students said, how about our animals? We should keep them also in solar heated sheds. So the students built a solar heated cow shed that you can see above. The beauty is that the food of the cow, which is straw or hay, is kept in the north side of the cow shed. You can see there is a door behind the main door, and there in autumn you fill hay or straw, and the food becomes insulation for the building, because north is where it is cold, south gets sun. So the food becomes insulation, and you can see inside the cow gets its food from that hole without people having to move straw from in bags and so on. So it's ergonomically beautiful, and thermally also, because now the cow shed is insulated. On the south side, it is painted black, and a plastic greenhouse comes down in winters. So the shed remains at plus 12 degrees roughly. And very interesting thing happened. We did it out of empathy for the cows, but as if they were happy, Gai Mata was happy, they started doubling their milk production. Now we were all surprised. We didn't expect that. Then we connected it to our biology lessons in the school. If you remember, there are warm-blooded animals and cold-blooded animals, and cows and humans being warm-blooded, we both need to keep our body temperatures at 37 degrees. So when it is minus 10 or minus 20, to keep our bodies at plus 37 needs a lot of energy. So the poor cow, most of its food goes in just keeping its body warm. So of course it cuts milk. And that's why in cold places like Ladakh, cows dry up, they say. They stop giving milk, or very little milk comes out. Now the idea here is that instead of giving them food to heat their body, give them cheap solar heat. Their room is warm at plus 12, so there's so little they need to do for heating, so that they can give more milk from the food that is saved from heating their bodies. So the cows start productivity, much better productivity. Similarly, if we provide solar heated cow sheds all over Ladakh, cows may double their milk production. There's an experiment here. We are still working on it. You can see this cow shed, because it is warm, it can also generate biogas, because warmth is a challenge for biogas in high altitudes. We are working on a system where the biogas tank with solar heating of the cow shed will stay at around +20. So even in winters, it will generate biogas. So the dung that comes out goes back into the biogas feeder and then gives us gas to cook, and the residue goes to the farm as food for the plants, as manure instead of artificial fertilizer, which I spoke a lot about. So this is how futuristic technologies can be. It need not only be, digital and robotic and chemical based. It can be creative and harmonious. Similarly, we have been doing greenhouses that even in winters of Ladakh can be very warm, always above freezing temperatures. 6 to 36 is what we observed in double glazed greenhouses, where you can produce almost anything in January. Very good work is being done in this regard by Bihar, and I'm so happy that they are giving this technology together with UT Ladakh to all the farmers. So a lot has been done, and there's a lot of scope, even more, to do in greenhouse technologies, because so far we think of greenhouses as something that helps us farm in winter and provides us fresh greens in winter. That is very true. But even more importantly, what I observed is that it is a great conserver of water. Greenhouses need half or 1/3 of the water that open gardens need. So I would always say, if I was a farmer, I would not leave my fields fallow in winter and farm in summer. I would do the opposite. I would farm in winter when nobody else is farming. There's enough water, and in greenhouses which do not need so much water. And in summer, when everybody is struggling for water, I would leave the farm fallow, dry. So greenhouses are a very interesting way of conserving water, and we should promote it as such. If much of our fields in Ladakh are covered with greenhouses, then water usage will go down drastically, especially in winter when we get crops that are so well priced because there's scarcity in winter. So you get 2 to 3 times the price, and you use 2 to 3 times less water. What could be more beautiful than this? So another futuristic sustainable and restorative technology would be greenhouses that are thermally very efficient. More work needs to be done in this to make them even more thermally efficient and water efficient, and much of Ladakh's needs will be met by greenhouses and also water wise. So this is life at our school campus that I call beyond modern. Beyond modern, because modern can be very destructive. It is modern agriculture that is causing so much pollution when artificial fertilizer factories are, guzzling oil and coal and spewing out carbon dioxide and monoxide and all kinds of pollutants. It is beyond modern when you live with animals. These animals, hybrid between yaks and cows, they are called zoos. They don't need diesel. They don't produce fumes and emissions. They actually eat your waste, and their waste is food for the farm, for the plants. They eat plant waste, and their own waste is food for the plant. So beautiful circular economy there. Everything that comes out of them is a resource. Whether it is their urine or their dung is a resource. Unlike tractors, it's deadly poison. And to buy your diesel, you have to take loans and then get trapped in the loan system. Whereas here, it's a beautiful circular economy. And that's what we want our young Ladakhis to train in, so they don't forget these beautiful harmonious systems in this razzmatazz of modernization, blind modernization. So we try to keep them connected to the earth and to the rural lifestyle by having traditional kind of agriculture at our school itself. In the background, you see these buildings. They are again beyond modern, because modern is these rooms and buildings which stay at plus 22 in New Delhi or New York. But for staying at plus 22, they destroy the earth. In New Delhi, you air condition to plus 22 when it is 45 outside. In New York, you make it plus 22 when it is minus 20 outside, and to do that you burn fossil fuels like there is no tomorrow. So that is modern, but it's not very wise. For your comfort, you're sacrificing the planet. These are beyond modern because they are solar heated. There's no pollution, no emission, no poison from these buildings, and yet they are as comfortable as in New Delhi or New York without costing the planet anything. Therefore, they are beyond modern and they are beyond sustainable. They are more than sustainable. Just like the cows and the yaks are beyond sustainable, they are restorative. Together with this building, when you don't burn any wood or any dung to heat this building in the background, you let the dung go in the farm, go to the trees, and make nature more enriched. That is restorative, that is beyond sustainable, that is beyond modern. Now, coming to our own waste, human waste, the most futuristic technology is again ancient. That's why I was saying ancient futures. The Ladakhi composting toilet, you can see on the left, and the Western one. Let's first look at the Western one. You grow food, you eat, and then you flush it in water, and it goes into the rivers and ground and lakes and pollutes. And then there is no connection further. Then it is broken here, and there are fuel guzzling industries that are producing fertilizer for the food for the plants. They are producing food for the plants from breaking air molecules. That's what I was saying when nitrogen is produced. So there is no circularity. On the other hand, in our ancient futures, we grow food also, we eat, but then it goes into the compost toilet, it decomposes into NPK, usable, and goes back to the soil, and it becomes food for the plants, and then we eat, and it's eternally sustainable circularity, and that's the beauty. So now what we are doing at Hayal is innovating to make toilets that are sustainable but also comfortable. Till now, there was this compromise, traditional toilets are not comfortable. Modern toilets are comfortable, but they are polluting and wasteful. So we are adapting traditional composting toilets to become comfortable and hygienic and clean. You have water spouts if you need. You have shredded leaves in the box on the left, which is used as a covering material. After you use the toilet, you put shredded leaves from the trees, and they decompose together with the human waste and become beautiful compost manure, either in vermicompost or direct microbial composting. So this is the futuristic technology I would love to see, and not just some chemicals. Now, as I was saying, if you use science, you can make things beautiful and comfortable. So these are our solar heated buildings. Even when it is -20 outside, it is around +18 inside. And design is such that in summers they are the coolest buildings. So this is the beauty of understanding geography from class 8th and 9th. If you build a good solar heated building that is warm in winter, it will also be coolest building in summer. Now we are again working at Himalayan Institute of Alternatives, which is an alternative university, doing R&D to make it possible for all of Ladakh, Indian Army, tourism and hospitality industry, so that Ladakh truly becomes carbon neutral and a harmonious example for the planet. So some of these buildings that we tested at Hayal had very interesting outcomes. Again, for R&D in science, you will find it interesting. So these buildings that are solar heated stayed at around +20. You can see the orange line on top. 90% of the times it is between 18 and 25 degrees when it is solar heated mud buildings. And below in maroon, you can see non-solar heated buildings in Leh city. They stayed, but heated, non-passive solar, but heated with kerosene and electricity. They stayed at around 10 degrees average, even when they are heated, if they are not solar heated. So very uncomfortable. But then look at what happens to non-solar heated when they are not artificially heated. The gray one down there, it stays at -5 degrees, killer temperature. And the outside, you can see here, touches -15 at the bottom. It's the ambient minimum. So when it is -15 in January, the solar heated houses without burning anything, no high tech, but sustainable or regenerative technologies, make it possible to be, as I said, as comfortable as in New York or New Delhi, but without costing the planet. Now, this can save a lot of pollution and make it sustainable for everybody. Look at what happens to Leh in winter. This is a scene of Leh city. So much smoke coming from houses that are burning wood and whatnot, kerosene, coal, plastic to heat. So this is what becomes of Leh city. If all these buildings were solar heated and between 18 and 25, why would anybody burn anything? There'll be no pollution, no emission. Zero emission, carbon neutral Ladakh. That is what I would love to see. And the buildings that I shared about you also cut pollution in Punjab. This is the beauty of the thing. The blocks, the mud blocks we make, insulated mud blocks, have straw mixed in Ladakhi clay, and the straw comes from Punjab, where it is burned. Some 32 million tons of straw is burned, and we bring it to Ladakh, rescue pollution in Punjab once, and then make blocks to make houses that don't need any heating in Ladakh, so cutting pollution a second time in Ladakh. Now these straw and other biomass, if we find a way to economically transport, then they can become compost and manure in Ladakh also. You can see here we partly compost and are experimenting with using it as a biomass, and partly making thermal blocks for building houses in Ladakh. These are quick, prefabricated straw clay blocks that are insulating by nature. You don't have to use any other insulation when you build with these. They are lightweight, they are insulating, and they are prefabricated. You just have to assemble the house. Coming to towards the end, coming to solar, not just for heating, but for electricity. So far I talked about heating. So you don't need these photovoltaics for heating. Heating comes directly from the sun. Why waste sun on producing electricity? for other things like computers, like machines, you need electricity. And for that, at our university, we have this large solar power plant. But that's not what I'm trying to show. That's normal. Today it's happening everywhere. And in Ladakh, there are plans to make a gigawatt power plant, some 20 to 30 gigawatts in the deserts of Ladakh. So how can we make that project win-win for farmers in Ladakh and for users in the plains of India? Otherwise, they'll just take up the land from the nomadic herders of Ladakh and give power to Punjab and Delhi, but Ladakh will lose land. So how do you make it win-win so that Ladakhi farmers also don't lose? We did an interesting experiment on this 3 years ago. I'll share with you. This experiment was done in anticipation of the 20 gigawatt solar photovoltaic plant that the government is planning. Our theory or hypothesis is that solar panels are quite inefficient. They use only 20% of the sun. 80% goes waste. Only 20% is used for electricity. So there's so much wastage of land. On the other hand, plants need roughly 50 to 60% of the sun. Different plants need different, but only half the sun is needed. They don't need 100%. So think of a system where the roof produces electricity and the ground produces crops in cold regions like Ladakh. So on this hypothesis, until transparent solar photovoltaic panels come out, they are still in laboratory scale. They are yet to hit the market in a big way, but very soon there will be transparent solar panels in which 20 to 30% is converted into electricity, but the rest 70% will pass through the panel. So you could have a greenhouse which receives 70% sunlight inside and half is okay. So 70% is more than okay. So you could be growing crops below and generating power above. Now this will be very good for the shepherds in Changtang who produce pashmina. If you know, every 5 or 6 years, thousands of goats die because of untimely snow. So we did this experiment for them to grow initially for reserve fodder for such calamities, for such untimely snow. Can we have a greenhouse that grows fodder below and generates power above? So win-win. You get both power and crops for the farmers. Both are happy, the user of electricity and the farmer who has land. So in this, we were very happy to note early results that peas and other things that are very good for the farmers and the crops for shepherds grew very well. We are yet to experiment this on a farmland. This was done on a desert, a total desert. So it may have had some limitations, but they grew lush. We grew peas on it. And what was beautiful was that the greenhouse also becomes a rainwater harvester or snow water harvester. So in the far remote areas of Changtang where these gigawatt plants are coming, the greenhouses could melt the snow on top and that water trickles into the greenhouse and then keeps circulating. As I said, greenhouses need very little water. So you may not need any water extra except for the harvested snow and rain. And warmth comes from this transparent or semi-transparent solar photovoltaic panels. And the nomads get their crops and plains of India get their electricity. I won't go into too many details. It will get longer, but I'll just add some things because you were interested. So as climate change advances, Ladakh's glaciers are melting away. Learning from an elderly Ladakhi engineer, Abba Norfelle, we started making different forms of artificial glaciers. This was the vertical glacier called ice stupas, so that it doesn't have other problems that were associated with horizontal ones that would melt prematurely. So they are very simple. This is a typical Ladakhi village where there is a stream and there are farms and a village. Now the problem is that the streams are very small in winter and in spring. In spring, it becomes a problem because it's time for growing crops and the water in the stream is very little because the glaciers are still cold. So the other fact is that after summer, July and August, there are actually floods, too much water when the glaciers melt. And this big flow continues into winter even. In January, February, there is some flow because nobody is farming, so the water goes waste into the Indus and then into the Arabian Sea. So we said, let's use basic science, primary school science, and freeze water in vertical cones like this. So all you need is a pipe from upstream and bring it downstream where you need water. And primary school science says that water always maintains its level. So the inlet and the outlet of the pipe will have same level. Water will want to go out to the same level, and against this force of gravitation, you put a fountain and water starts gushing into the air, into -20 cold air, where it loses its heat that keeps it liquid. And if you remember, it's called latent heat, where it loses its latent heat and becomes solid in the form of a cone. Now, a cone is such a shape. If you remember your high school geometry, a cone and a hemisphere would have low surface area for the given volume. This is beautiful because the sun needs surface area to melt ice prematurely. So it doesn't get that surface area, and therefore these should stay long into summer when farming starts in April, May, June. We have to keep ice from January till June. So this shape helps because the surface area is low, but farmers need volume, not surface area, and volume is high in these shapes. So farmers get their volume, sun doesn't get its surface area, and therefore these giant mountains of ice, this one had 30 lakh liters of water, the first one had 10 lakh liters. They can then melt in May and June and help green deserts that were never green. In Pyang, these were 5,000 trees planted, which were watered by a melting ice stupa. Now it is like a movement in various villages in Ladakh, Leh, Kargil, and then across the border in Baltistan, Skardu, and Sikkim, and even Bhutan is interested, Nepal, and in Switzerland, Czech Republic, Chile has been doing. So many countries, people are attempting this. The technology is still crude, I must say. We are working on automation of the whole system so that it becomes less labor intensive. Right now, it is a little painful. So there's work going on in automation, and then it would be a very interesting way of reserving the winter water into summer. And here's how people became creative in financing these water towers by connecting it to tourism, winter tourism. So inside ice stupas, you can have ice cafes or even ice climbing is a great sport nowadays. And similarly, we look forward to having ice hotels, which are very, very expensive hotels in the world. But in this case, it will be financing water. It will be tourists' experience and farmers' water together. And among futuristic technologies on water, one thing we are working on is to make ice stupas from glacial lakes that are forming. With climate change, the danger is that not only our glaciers are going away, but they are making lakes which then burst into floods. So we are working on refreezing these lakes so that they can become a source of water rather than only a threat, which reduces the threat of the lake by reducing its level and freezes it so that in summer you will have more water. I'll keep it here. Thank you very much. I think I overshot my time. Thank you.
Thank you very much. Anupriya?
Thank you very much for such a nice talk. The window is now open for questions. If anybody wants to ask questions, you can feel free to chat and ask your queries.
I believe Mr. Tolden from Leh has raised his hand. Mr. Tolden, you can ask your question, please. Mr. Tolden, if you are there, you can ask your question. You have raised your.
Yes, sir. Very good morning to Shri Sonam Wangchuk, Director Health, Shri Sanjeev Bhosla, Director CSIR, and all the participants, especially to the organizer, Mr. Chandrasekhar. Sir, looking to into your slides and all, I've learned one thing that SECMOL has been using solar electricity since late 1990s, right, sir?
Yes.
When most of the Ladakhis had no idea of what exactly the solar electricity is. And sir, recently I've seen that in Ladakh now most of the hotels, guest house, and homes, they have started adopting the solar electricity one. They have either they buy the solar project from the Lareda and Kareda, or they buy directly from the local market. But what I've learned in the past few years, I was a bit researching about the solar electricity on that, sir, the cost of production of the batteries, the lead acid batteries, the mining it involves, the disposable of batteries, it is a huge matter of concern. Although we have never, sir, taken it into this thing. But what I feel that when this 20 gigawatt power would be installed in Ladakh, and moreover, if most of the households will get converted into this thing, solar electricity and all, the cost of the disposal of batteries plus the production of the batteries could, it's going to be a big matter of concern. So I just wanted to hear what our respected guest, Shri Sonam Wangchuk, has some say about this one. Thank you, sir.
Thank you, sir. Thank you very much. Yes, thank you. Ladakh has been a very early pioneer in solar power. I don't take the credit. Even before us, there were many people like C.L. Gupta ji, who was pioneering the first solar heated buildings, and then Ladakh, of course, and Jerez, and then we took it forward in the modern level. So thank you. The thing is that Ladakh's energy needs, according to a study by Ladakh, 90% is heating and cooking, and only 10% is electricity. So we should not give too much emphasis on electricity alone. Our bigger need, much bigger need, is heat. And for heat, you don't need solar photovoltaic panels, nor do you need batteries. So always take heat directly from the sun. For heat, your batteries can be your black wall. And nowadays we use even water, which are not polluting. So water can be a great battery for heat. Only for the 10% need, we should go for electricity. And there also, we should make the conditions optimum for batteries so that they don't go bad before time. So therefore, battery houses that are solar heated are very important, because batteries perform their best at 25 degrees. Now we have places where it is 5 degrees, 0 degrees battery house. Then we generate a lot of waste because batteries go bad very soon. That is the way to approach to conserve battery life and use it only sparingly for electricity? First answer. Second answer, you will be happy to know that the gigawatt plant does not have batteries. It will not be with batteries. Otherwise, you're right, it will be a nightmare if 20 gigawatt power was stored in batteries. Now, the good news is that that will be direct evacuation through lines as it is generated during the day. So there won't be much battery waste created. But near Leh, there is a 50 megawatt solar power plant coming, and of that, a big chunk has battery storage. We should make sure that they use very efficient battery storage conditions like heated battery banks, so that batteries are not disposed of, in 3 to 5 years. They last 8 to 10 years when they are given good conditions. That much we'll have to do if we go for electricity. Ideally, we should not store electricity. We should use directly from the sun. Thank you.
Dr. Sanjeev Khosla, Director CSIR IMTECH.
Yeah, thanks, Chandrasekhar. Great talk, Dr. Wangchuk. Actually, it's a fanboy moment for me as well. I've always been a fan of your scientific logic that you use for all the innovations that actually you drive. I think so. One thing that I just wanted to say was that it's very important, as you said, looking at what we have been actually taught through our through the ages from our ancestors, and I think so it's very important that we do it, but it's also important for us in this generation to look at the logic as to why we did or we've been doing these things. For example, I just tell you one example of what when we went to meet the people in Himachal for looking at the natural farming was as soon as we actually looked at the flow of things that were happening in the natural farming, the way they were actually making these solutions, we could realize very quickly that whatever they were using in the natural farming was actually promoting a particular type of microbe, which we don't know what it was. But I think so it's important that we utilize these informations to promote what we already knew, as you said, ancient future. And I think so very important what you said. And thank you very much for this lovely talk. Thank you.
Thank you. Thank you.
Sir, one of our guests, Dorji Staring, has a question that we are informed that Ladakh and high altitude places are feasible to use the solar energy. However, in some places in Bhutan, we have very cold places where there is no proper sunlight, where we cannot trap solar energy. For such situation, do you have any idea or innovative ways to go eco-friendly ways to promote environment?
Okay. Thank you, Dorchila. One thing is that solar power is becoming quite affordable. So even not as sunny as Ladakh, you can still harness solar energy. For example, Europe hardly gets any sun, but they go for photovoltaics because now it is affordable. So I think your area may not be worse than Europe. So you should still go for photovoltaics only for electricity, Rest, you need not photovoltaics. You can direct use sunlight for warmth and so on. So photovoltaics still may make sense is what I'm saying. And even in cloudy weather, they still produce some 30 to 40% power. Photovoltaics doesn't mean that it has no power production at all when it is cloudy. So they may make sense. Secondly, where it is cloudy, you might also have water more. So mini, micro, pico hydropower might be a very good solution for you in such places. I know Bhutan has many streams and waterfalls. So that could be another use. And you are making a lot of hydropower, I know. So we have to make a mix of energy sources, and similarly wind could be another. But I still think solar is usable even in most parts of Bhutan, although it has less sun than in Ladakh.
Okay, thank you, sir. Sir, our guest Abhishek has a query that might there be any disadvantage of solar, because after all, it is also an unnatural way. It's artificial, man-made. Are there any chances in reduction in the reflection of the solar heat and increases in more and more absorption of the heat?
I don't think that as much because solar photovoltaics may absorb, but then there's as much radiation also in lower wavelengths. So that may not be so much of a problem, but I think you're very right in that we should not only look at production side. We should not look at only supply side, how to produce more and more electricity. We should look at demand side. How can we require less and less? How can we live a life that requires less energy than we do today? I'll give you another very good example from Sekmol School. Good that you reminded me. Many people ask me, what is your favorite solar gadget at this school? We see so many solar lighting, heating and gadgets and so on. What is your favorite? And I tell them my favorite one is not a gadget that you can touch. It's a concept. So what it is, now listen carefully. Our school runs like a little country. It has its own little government made by the students. It even has a local standard time, Sekmol campus standard time, which is 1 hour ahead of Indian standard time. Now people ask me, what do you mean? You want to be a separate country? I say, no, nothing serious like that. We just want to make it easy for teenagers to go to bed early and wake up early in the morning. So if you advance your watch by 1 hour, people go to sleep at 10 thinking it is 11, and people get up at 5 thinking it is 6. It's easier. In short, what I'm saying is we need to also change our lifestyle. If we stay up till midnight or 1 a.m. and then brag about solar and sustainable technologies, it would be a futile exercise. You have to live sustainably also. So our ancestors went to bed not too long after dark. So therefore, we need to also sync our lifestyle so that we go to bed soon after dark and get up early with the sunrise. Our windows are the best solar lighting device, I can tell you. They are the best and cheapest solar lighting device, but that happens at 5:36 in the morning. You have to wake up to that instead of sleeping till 8, 9, 10, given a chance 11. Teenagers these days, they sleep in the mornings when the sun is up and then talk about solar lighting. Well, solar lighting happens free of cost and naturally at 5 or 5:30. Use that solar lighting and don't keep up till midnight. Your life itself will save the planet. It doesn't take a lot. So I tell people that you can save the planet by just sleeping right. If 7 billion people sleep early and wake up early, imagine the number of power plants that can be shut. Thank you.
Okay, thank you very much, Dr. Sonam Wangchuk, for such a wonderful speech and showing us such natural visuals from Ladakh and turning science concepts alive by implying it in real life. And thanks for letting us know about the true development that we have inherited from our heritage, like not to waste food, live a simplified life, learning values from ancestors, and tips to educate our next generations not to waste our natural resources, but to recycle and reuse them every single time, ultimately to save our Mother Earth. Thank you again for inspiring young minds to always think out of the box and live simply. You are really doing a great job, sir. We really need more innovative schools like SECMOL where early ideas get nourished. Your innovations in making the ice stupas, solar heated smart buildings, solar car parking, greenhouses are indeedly remarkable. We wish you stay in touch with our STI hub in order to bring the best out of the people from Ladakh. Thank you, sir.
Thank you. Thank you very much.
Thank you, Dr. Sonam Wangchuk. Before we move further to hear Mr. Tashi Setan, I would like to thank you again, sir, on behalf of CSIR, IMTECH and the team STI Hub for accepting our invite on a very short notice. I know we troubled you a lot in last few days, and I really thank you for accommodating us. And we know that you had a really important meeting scheduled today at the same time that you are delivering lecture here. We sincerely thank you, sir, for taking your time out for us and talking to us, sir. Thank you very much, sir. Thank you very much, and also to your team, sir, Miss Michelle, who coordinated everything so seamlessly. So I sincerely thank you, sir, for taking your time out and talking to us, sir. Thank you very much, Anupriya. Yeah,
it was a pleasure. It was a pleasure, and yeah, look forward to collaborating.
Yeah, thank you very much, sir.
Thank you, sir. Now I would like to welcome Mr. Tashi Setan on our today's virtual meeting. Mr. Tashi Setan is the Chief Agriculture Officer of Leh Ladakh. In addition, he is also a Mission Director Organic Farming of Union Territory Ladakh. Very welcome, sir.
Good morning, everyone. Thanks to STI Hub Ladakh, NILET, and the organizer CSIR-Institute Chandigarh. Dr. Sanjeev Khosla, Director CSIR-Institute Chandigarh. Dr. Sonam Wangchuk, Director HIAL. Good morning to all. Well, I'll tell about the agriculture activities in Ladakh. The topic was given like that. And I will tell that how traditionally, previously in our traditional system, how agriculture was going on, and in between what happened to the agriculture system, and what is our futuristic strategy to increase our production and how to go with the sustainability of agriculture. In Ladakh, traditionally the agriculture system is basically meant for self-consumption and self-subsistence. Whatever they produces in ancestral time, they just store it for the winter purpose, because whatever they produces in the summer, they have to depend on that, because they don't get any supplies from outside. Whatever they produces on their field, they have to depend on that. So in Ladakh, whole family, most of the Ladakhis are dependent on agriculture, and whole family members work as a agricultural labor, and they produces various types of types of vegetables, and the main cereal crops was barley and wheat. Barley actually covers the major portion of the area, and they actually, whatever they produce, they store it for the winter purpose. And most of the people are knowing it that Ladakh is a monocrop culture. In Ladakh, we get only one crop, single crops. In other parts of the country, we get 2 to 3 crops. That's in Rabi crops or Khabi crops, like we said in common language, summer and winter crops. But in Ladakh, we get only single crops, that is in summer, which starts from April and ends by the end of October. So during these periods, whatever we grow, this is our production. Previously, few types of vegetables are growing in Ladakh, mostly radish, turnip, local sweat, potato, cabbage, and some leafy vegetables. And whatever that remains with the surplus, though they used to get other items which requires other essential items which required for their family purposes. That time, in early times, the nomads people, they used to bring butter, wool, salt from their places to sell in lower places of Ladakh. So they come into the villages, and the villages, they sell their produces, surplus produces like grains or vegetables. It is a sort of a barter system, they exchange items with another one. So the nomads people, they used to give them butter, wool, or salt, and the villagers, they give them the grains and vegetables. So their life was going on. And in late 60s, when the defense personnel's army's development was increased in Ladakh, in border areas of Ladakh, that time it was felt that yes, agriculture farmers requires to grow more vegetables because the army's requirement was increased. So by then the people started to growing more varieties of vegetables. They increased the production and then sell it out to the armies. So that from then that very time people started earning out of agricultural produces. Now the farmers of Ladakh, they are growing commercially, especially the potatoes and the peas. They are growing in a very large scale, and they are selling it to the, of course, into the army as well as in the market also. In after 70s, after introduction of tourism, the demand of vegetables were again increased. And then the Department of Agriculture started procuring various types of vegetables, different types of vegetables, and distributed among the farmers of the Ladakh. People with the farmers not knowing properly to how to grow all the varieties of vegetables. Then the department started giving them training, awareness camps, and giving demonstrations in their fields, in the villages, how to grow the varieties of vegetables. Now the farmers of Ladakh are growing above 22 varieties of vegetables successfully, and of course it supplies to the army and earning a good amount out of that. And the major crops growing, commercial crops, I should say, in the vegetables growing in Ladakh are peas and the potato. So this potato was growing since a long time, but I have seen that since a long time, the replacement of seed does not occur. And after the formation of this UT recently, then we just put a proposal that its requirement of seed potato seed replacement is very much essential. Then this very year, we procured around 3,000 quintals of certified seeds from Himachal Lahore Potato Growing Society, a registered society, and we bought around 3,000 quintals of certified seeds, which is coffee Chandramukhi and coffee Jyoti, and distributed in the potato growing areas of Ladakh. And by next time, hopefully, we are expecting a very high yield from those areas. And likewise in peas, fresh peas, when the fresh peas matures here, that time in rest of the Indias, they don't get the fresh peas. So we last 2 years we are procuring pea seeds and distributed to the farmers around 300 to 400 quintals. But this year farmers' demand was high, and we procured around 700 quintals of pea seeds, and will be distributed in the coming season. Well, likewise in Ladakh, we have many fallow lands, cultivable lands are available, but most of the areas are uncultivated and barren. The reason is that we don't have the irrigation facilities. If we have the irrigation facilities, of course, we can bring those areas into under cultivation. So after formation of UT in Ladakh, we got enough funds, abundant funds, and we got also central sponsor schemes like Pradhan Mantri Krishi Sanchai Yojana. A scheme was that micro irrigation, and under that micro irrigation, we distribute to the farmers on subsidized rate sprinkle and drip irrigation. But if we go for the another system in which we have to develop the land and we have to create the irrigation system, of course it may take a long time, and yes, it costs very costly. And this drip and sprinkle irrigation, we can simply lay out the pipes in the undulated lands where we don't require the land reclamation or any construction of irrigation canals. So this very year, department here covered around 600 canals of land, cultivable lands, and provided with this sprinkle and drip irrigation, in which the farmers are going planted fruit plants, and then mostly planted the cucumber beet plants like watermelon, marshmallow, summer squash, and bottle gourd. And in the coming years, of course, this scheme will continue, and we will, of course, we will distribute to the farmers again, because we have a lot of area available in Leh, especially in eastern areas and in northern areas of Ladakh. So we have kept abundant funds for the future. So everybody knows that in Ladakh the water scarcity is going on because the glaciers are receding. So to conserve that, we have introduced another one more scheme, that is conserve moisture. To how to conserve moisture? To conserve moisture, we have introduced a scheme that's called mulching. Though the technical is very simple, very easy. The main function of this mulching is to conserve moisture. In Ladakh, because of dry arid area and the cold, and even in summer, the temperature is very high, scorching heat. So most of the water, when we irrigate in the fields, it evaporates, and we require frequent irrigation into the field. To avoid the moisture, to check the water, check the irrigation, we started giving them mulching, black polythene mulching of 100 to 200 microns. And first thing, the function of this mulching is to, of course, conserve moisture, and second is to maintain the soil temperatures. In Leh, the fluctuation of temperature is very high. In daytime, its temperature goes very high, goes up to plus 35, and even in summer, in evening, again temperature goes very down. So due to fluctuation of times, the growth of the plant is not normal. By using this mulching, by maintaining of soil temperature, plant growth is robust. And we have seen that, especially in the fruit plants like tomato, brinjal, and capsicum, when we use this mulching, it enhances the maturity of the crops as compared to the normal one. And other important thing that by using mulching, when we add the manure, compost into the soil, most of the nutrient minerals, it evaporates in the air, and it disseminate in the air. So whatever we put in the soil, it doesn't get the nutrients actually to the plants. By using this mulching, the plants able to take the nutrients whatever we put into the soil. So these are some importance of mulching, and of course we are using it. In future, it will really a good thing for the farmers. And department is also providing machineries on subsidized to the farmers. As you rightly said that many years back, the farmers are using Zo, which is of course the progeny of cross between yak and cow, which is of course very robust one as compared to the ox. But farmers, we have seen that these ox are used only in the spring and in autumn, but we have to feed them throughout the year. So it's really a burden for the farmers. And of course in most of the areas people are still using it, but in many farmers are demanding that they require power tillers. So departments are providing small power tillers on subsidized rates. Likewise, greenhouse, which is very important scheme of Ladakh. This is a very long story that long back the greenhouse was used as a solar greenhouse in which we use glasses as a greenhouse in which farmers started growing vegetables, but to somehow it's not satisfactory. It's not come true what we required. And then poly greenhouse was introduced. It was more or less accepted by the people and using very largely. And we came to know that in China, that in the northern part of China, that poly greenhouse is using very popularly, and they are growing vegetables even in minus temperature. So our department, agriculture department, has deputed some officers to the northern part of China, Chengdu, and they have seen their technology, and we have tried the technology in Leh, but somehow it thrives well. But whatever we want the result, we could not get the result when we wanted to. And lastly, last 2 years back, DRS evolved a new technology that is polycarbonated greenhouse. Really is very good. They have tried their farms. And this polycarbonate greenhouse actually used in European countries and many other countries, but it is costly for the farmers to bring their own. So DRS started researching in this, and they last year they have transferred the technology to the Department of Agriculture, and we are distributing it to the farmers. And last year we have first after transfer of technology, we have tried this polycarbonate greenhouse as a pilot project in some villages, and we have seen that in this polycarbonate greenhouse during peak winter, when the temperature outside is minus 30 to 35, that time the minimum temperature inside the greenhouses remain between 8 and 10 plus. So we can grow easily all types of vegetables. But DRS has also shown that in the peak winter, that's in the month of January, they have shown harvesting of tomato, broccoli, and cauliflower. So if people wanted to grow these vegetables, easily we can grow in winter also. So to use this greenhouse in large scale, we have kept this greenhouse in a plan, and UT of Ladakh has earmarked an amount of rupees 40 crores for construction of greenhouses. And we have finalized this in two sizes. That two sizes of a greenhouse. One is 60 feet long and 24 feet width, and second one is 32 feet long and 18 feet width. These two sizes we have given because the farmers or entrepreneurs who wanted to grow commercially, for those they can take the bigger one, that is 60 by 24 size greenhouse. And the 32 by 18 greenhouse, we would like to distribute it to the whole farmers of the Ladakh, individual farmers of the Ladakh, so that the whole Ladakh would be self-sufficient in vegetables during winter. And we are trying to disseminate this technology all over UT Ladakh. And of course, we are on it, and around 200, above 200 numbers of greenhouse have been constructed this very year, and people are producing vegetables. And this 60 by 24, we are giving to the program. Can give 5 numbers of this type of greenhouse to the one entrepreneurs also, if people interested, if people are any educated entrepreneurs wanting to do that. So our aim is to achieve the goal that during winter that we won't get green vegetables. If you wanted to have vegetables, we have to bring through air, with really a very costly. After availing these facilities, Ladakh would be self-sufficient in green vegetables in winter. And likewise, the main target of the UT Ladakh is to convert the whole Ladakh into organic. That is, UT Ladakh shall be the first UT of India to be declared as organic. We all know it that Ladakh is by default organic. Traditionally we are only eat like organically, and the chemical fertilizer or chemical insecticides we are using very least, very minimum, very negligible. And also nature has also given to us that because of the cold climate, cold temperature during winter, the temperature goes down up to minus 30 to 35 degrees centigrade. Due to these convergence, most of the insects, the kills, they die because of the low temperature. Summer season, the pathogens incidence. So again, one advantage for going to towards the organic. Secondly, the water we are using for the cultivation of these vegetables and agricultural crops, all glacier snowmelt water, which is very clean. There's no any effluent water waste. So whatever we use for the irrigation water is a pure and clean. And secondly, the air of Ladakh, there is no pollution at all. Air is very clean, and of course, sun is remains very sunny out of 265 to 50 days of sunny in Ladakh. So the incidence of pests and insects and pests is very less as compared to the other parts of the area. So to convert whole Ladakh into organic, our Lieutenant Governor Mr. Mathur and the Ladakh Autonomous Hill Development Council of Leh and Kargil both launched a scheme which is called the Mission Development Organic Initiatives. The Mission Organic Development Initiatives, in short, it's called MODI, will target to be achieved by 2025. So department have drawn a roadmap that how we can achieve this by 2025. So to achieve this goal, we have made it in 3 phases. So how in 3 phases we have to convert the whole Ladakh into organic. In the 3 phases we have made it in 3 categories. The categories are, we made that the area, we have chose the area, we have selected the villages area where the farmers, the villagers have not even used chemical fertilizers or insecticides. And the second category is that we have taken into the second phases are those areas where the villagers or the farmers uses more than 5 tons of chemical fertilizer or any sort of insecticides or pesticides. And the third categories which should be taken in the third phase is the area where the farmers or the area are using more than 5 tons of chemical fertilizers. So in the first phase, we have just studied, we have surveyed. Then we came to know that in both Leh and Kargil, around 66 villages are there which have never used or not used for the last 10 years any type of chemical fertilizer or any insecticides. So we have registered those villages, those areas for certification of organic. And we after finalization of that, it was started in 1919, and last year we have sent it all the biodatas of these villages to the Government of India, farmers of Ministry of Farmers Welfare and Agriculture, and this very year they have issued the organic certification to these 66 villages, and this certification are coming on. So in the second phase, that is by 2023, we will declare the second phase. In the second phase, the farmers, the villages, where the farmers are using less than 5 tons of chemical fertilizers. For this converting these areas into organic, of course, we are facing some challenges that farmers are asking that, of course, they are using less than 5 tons of chemical fertilizer in the whole villages, but they said they need some replacement for these chemical fertilizers. They need some chemical insecticides, pesticides. So under this Mission Organic Development Initiatives for the replacement of these fertilizers, we have made some plan that each farming families will get a compost pit. For construction of compost pit, we are giving 50% of subsidy, in which farmers can make their own compost. So the compost size is varies. It starts from sizes bigger from 50, 30, and 15 feet size. As per the requirement of the farmer, they can have it, and we can provide them the subsidies. And this in this pits, the farmers can put all the organic matters, whatever they are, whether it's cow dung or any organic matters, or in its fallen leaves or kitchen waste, whatever they have, the waste, biodegradable waste, they can put into the pits and then cover it with a black polythene. Of course, they are too providing by the department. And of course, Ladakh is in high altitudes. Climate is cold. It takes time to decompose, and many people complain that it doesn't compose properly. And most of the people know it, and we have distributed to the farmers of Ladakh. The National Council of Organic Fertilizers, Government of India, has innovated a organic waste decomposer, which is a quick decomposer. For example, organic matter, it takes 1 year to compost. It almost decomposes in 6 to 7 months. So it enhances the decomposer. So this decomposer we have in the department, we will provide it to the farmers. For that, it requires 200 capacity liters of barrels and some molasses and 2 kgs of good, which we call good molasses. The two provided by the department. So what in each villages, in each farmers, we are covering this. We are providing with 2 barrels of 200 capacity of barrels, molasses, and this waste decomposer. And of course, we teach them, we train them how to make these liquid fertilizers. It's very simple. If I tell you that just put 200 liters of water in the barrel and put this waste decomposer into it and add 2 kgs of this molasses into the barrel and stir it, keep it for 10 to 15 days. It will decompose, it will ferment it. After fermentation, of course, it's ready for the use. You can use directly into the field, and whatever the organic matter in the soil, it decomposes very quickly and the plant gets the nutrient. And as a decomposer, as I told you in the compost pit, when you put all the organic matters in the compost pit, you can put this liquid form into the compost pit. It enhances, it quickens the decomposed and decomposes very quickly. So by next one or 2 years, hopefully we will get this compost from the farmers and they can use easily into their farms. And likewise, we are also bringing some fertilizer also as a replacement. And the farmers who are rearing these animals and farmers who are doing dairy farms, we are also providing them this compost pits. When the waste product, I mean the excrete of the cow dung, we can put into the compost pit, and we are providing them with earthworms. So whatever they get the waste, I mean excrete of the cow dung, they just put into the compost pits and put this earthworms. Easily after a few months, these earthworms convert this dung into a compost one. So we will get the compost, wormy compost from there. So after fully converted into the compost, we will buy it. Farmers are ready to buy it. So again, the dairy farm, they can also earn out of that. For this, achieve this goal, this conversion of organic farming, Department of Animal Husbandry, Sheep and Husbandry, they are also providing subsidies for increasing the livestock, so that we can get the cow dung for this making compost and all. We are planning to do that. Most of us knowing it, that in Eastern Ladakh, we call Changtang, there are people who mostly depends on rearing of animals like sheep, animals, and yaks. So now there they have a lot of cow dung, I mean manure there. So they don't use in agriculture. So we are planning to give incentives, subsidies to the entrepreneurs they buy these raw manures from the eastern people who are rearing these animals and then convert into the compost by the same method, and they can sell it into the other required farmers. So one entrepreneur can easily earn out of that. So this is in plan, we can do it. And even in Ladakh, we have a very good scope of floriculture. Last 2 years back, we are trying in this floriculture, especially the flowers like Geladulus and Lilium. It really thrives very well. It blooms very well. The color of the flower is very particular because of the bright sunshines. Color is very bright, and we have seen that in the Geladulus, the height is very good, and the flower rates actually the having grades. All we have seen is in Ladakh, whatever we're growing is A grade size, which is more than 12 florets. More than that, we can multiply the Geladulus bulbs, Dahlia bulbs, and Lilium bulbs. Whatever we multiply bulbs are disease-free, pathogens-free, insects-free, and we can sell it out to the other markets also. So these are some department futuristic in agriculture. So I hope most of you got it what I would like to convey. So with these words, thank you. I close my chapter. Thank you much for hearing me. Thank you.
Thank you, Rakesh sir, for talking to us. I request Anupriya to take some questions.
Yes. Sir, we have a question from our guest, Rigzin Dole 97. Sir, could it be possible to take initiative on hydroponic style?
Yes, we can take the hydroponic styles, but it should be in the large scale, because in Ladakh it's always, and these days we are going on a very small scale in the greenhouse. If you go for the large scale, then of course hydroponic could be a beneficial one. If you go for the commercial scale, then yes, it would be a beneficial. Otherwise, if you go for the small scale, like we are starting with the greenhouse, I think it won't thrive.
Sir, one more question. What kind of facilities are available for medicinal plants grower from the agriculture department?
Right now, the medicinal plants we are now dealing actually is dealing by the Sawarikpa, one other department who are dealing it. But of course, we are providing facilities like the drip and sprinkle irrigation. We are providing them on 75% subsidy. Those who wanted to grow the medicinal plants, like sir, we have got some plants from the CSIR Palampur, some hink. We have also tried in our farms. They thrive very well. It's working very well. If it thrives well, then it would be really a big revolution for us.
Okay, thank you, sir. Thank you very much, Mr. Kashi Setan, for giving us your valuable time and sharing your thoughts and views with us about the status of agriculture of farmers in Ladakh from past till now. As Ladakh is a cold desert land, making interventions so people start growing vegetables to sell and not only to consume seems beneficial. We got to know about more than 20 varieties of commercial vegetables that are produced by the Department of Agriculture, Ladakh. We also got to know about the polythene mulching technology, which is implemented to restore temperature and moisture. Thank you for letting us know about the facilities provided by Agriculture Department of Ladakh. We got a lot of information from your side, and it will be benefiting the small farmers and entrepreneurs also. We wish that you will collaborate with our STI hub in future in order to bring the best out of the people from Ladakh. Thank you, sir.
Thank you very much for having me. Thank you.
Thank you very much, sir. For letting our participants know how good agriculture department is working closely with the farmers of Ladakh, even though if those are the marginal farmers, and you are doing really a great job for the society, sir. Thank you very much. And with that, I thank both the speakers, Dr. Sonam Wangchuk and Mr. Tashi Setan, for joining us for the inaugural session. I believe our participants got to learn a lot of things from both the speakers. So with that, I formally announce the the end of this inaugural session, and now we will be moving forward to the our first session that will be focused on agriculture, and tomorrow we'll be having more sessions on livestock and the renewable energy sources. So with that, I request Anupriya to take over and start with the first session that is on agriculture. Thank you, thank you, thank you, sir. Thank you, Dr. Sonam. Thank you, Mr. Tashi, for joining us, sir. Thank you, sir.